Today, we will talk about variables and standard I/O. In there, I/O means input and output. Variables. All the data in our machines are just some dumps or blobs. If we want to store our data to computer, we need to find out some unoccupied space and remember the address we use, like what page, what memory, and the offset of the space. Most of programming language can help us do this smart by using variables. First, we declare like we need an integer named a. The computer will find an usable memory and store an integer and map the name a to the real address. After this, when we say a, the computer will know to find the specific integer for us. Now, it's time to learn how to declare variables in C language. To declare a variable, we need to set up the type and names. See example. Int a means we need an integer named a. Int b equal to 3 means we need an integer named b and its value is 3. We also can declare multiple variables in one statement. In this case, we should separate variable names by comma. Variable names are case-sensitive in C language. Case-sensitive means the uppercase and lowercase of the same alphabet will recognized as different names. We can name our variables by underline, lowercase alphabet, uppercase alphabet, and digit, but we cannot use digit as the start. We can see example. Apollo 13, underline temp, A5, Inazuma 11 are legal names, but 3M is not. Since programming languages are writing for human beings, we want our source code are readable and meaningful. The most simple way to do this is give them some meaningful names. If you want to use phrase as names, we usually use follows two approaches. First, camel case naming. Camel case naming means for each word in the middle of the phrase, we give them a capital letter. And the second, separate them by underline. Assign. In C language, we use equal mark to store data to variable at left-hand side. After declare, we will talk about I/O. Printf is the most popular standard output method in C language. Its F is from formatted. If we want to use printf, we need to include standard IO.header. The first parameter of printf is format string. The format string decides what we write to standard output. You can see the first example. Our format string is a equal to %d. A equal to %d means we want to output a equal to some integer value. Percentage pattern will exchange by follow parameters. In this case, %d will be changed by value of variable a. Just like printf, scanf is the most popular standard input method in C language. It's in standard IO.header too. Format string is sent as in printf, but care, we need to add end marks before target variables. We will discuss the reason at after chapter. Now, see example. Scanf %d white space %d means we will read two integers separated by a white space and store them first to variable a and second to variable b. Next, I'll present how to use percentage pattern of printf and scanf. You can see the syntax of percentage pattern. Square bracket means they are optional. Follow, I'll show their function. First, we see width. Width is the total width of the pattern. If the width is longer than your exchange content, they'll align right. If width is too short, width will be ignored. So we can write some program to try this. First, I write a simple program. You have a double floating point f. The value is 3.123456. The printf, I will print out the value of f. And now we can run this. Compile and run. We can see the value of the f. Now we want to try use setup width. If we give them some maybe longer width, maybe 11, and compile test.c and run, we can see the results are right aligned. If we gave some smaller width, maybe like 5, and compile and run, we can see the results are still the same as the original. The width of 5 are ignored. And we can see the next. The precision optional. The precision optional are an digit after dot, and it will set up how much precision digits are rounded off. So we also can try on our program. First, I gave them maybe longer width and add a dot. I only want to 3 precisions, so I write 11.3. Save it and compile and run. We can see our results have only 3 precisions. 4, 5, 6 are rounded off. And we still have other optional. Minus means align left, because we are see that if we set width, our content are align right. If you add minus, the result will align left. And plus, if we add plus at the pattern, we will show plus when our value are positive. And if we add 0 before width, our content are filled with 0. I think I can try this. First, we can try minus. Minus means align left. Compile and run. We can see 3.123 are not aligned right now. And first, we will try plus. Plus means it will show plus if our value are positive. And now we try this. Compile and run. You can see my value result is plus 3.123. And last, we try the 0. Zero means it will fill with 0 when your value are not long enough. So you can see our widths are filled with 0 to width 11. You can combine all the optional by what you want. Otherwise, if you are not want to set up a pattern, just want to read or print a percentage mark, you can write dual percentage to show that there are just a percentage mark, not a pattern. Just like percentage mark, if you want to use special characters in C, which we call escape characters, you should use patterns start with backslash. Backslash n means new line. Backslash t means tab. Backslash r means return. And if you want to use backslash, just the backslash, you need to write it twice. Now we are talking about the detail of types. Primitive types means basic type provided by the programming language. In C language, we have three kinds of types. They are integer, floating point, and character. First, we see integers. Integers is the basic type of most machines and languages. In C language, we can compute, add, subtract, multiply, divide, and module between integers. And we can see the corresponding pattern symbol in the table for different range integers. Next, we see characters. In C language, character is a kind of integer, thus we can use all the operation integer can. The only difference between character and normal integer is character can presented as letter. If we want to show some value as letter, we need to quote the letter by single quote mark. If we want to read or write character as letter, we use pattern symbol C. If not, use the other. Last, floating points. There are no definition about remainder of real number, so we cannot use module operation on floating points. We can only use add, minus, multiply, and divide with floating points. We can write floating points value by normal form or scientific form. You can see the example of these two forms and their corresponding pattern symbol in the slide. Maybe you'll have some question about how the program works between different types. In C language, compiler will convert variables to highest data type that appears in the statement. The highest data type means the data type can present or contain the max value is greater. In simple, floating points is greater than long, greater than normal integer, greater than short, and greater than characters. In floating points, long double is greater than double and greater than float. In other integers, unsigned is greater than signed. Unsigned means the integer can only contain 0 or positive integer, and signed integer is the normal integer we use. And I made a little chart. You can see some example. In this chart, you can see double is greater than unsigned int, and unsigned int greater than int, and normal int greater than character. Otherwise, if you store a floating point value to an integer variable, compiler will run down to integer part. For the same reason, if we divide integers, since the result will process and save as integer, the decimal part will be ignored. For example, we can write a simple program. In this test, we write 5 divided 2. Since decimal part will be ignored, we compile and run. We can see the answer is just 2.